Okay, dear students, so this is the recording for the next topic, which is interrupt. So, under this topic, interrupt, you see in the previous topic in chapter 4, like for example, when you have the start of the program, right? So, let's say you have the main program, then assuming you have particular line, then how do you actually call the subroutine? So, either you use rcall or call. So, we have seen in our class before that we can actually, like for example, call, delay 1 second, for example, right? Then you have the next line, and then of course you halt the main program where you can actually put no operation branch again, for example. So again goes here. So this is just an example to show the part of the main program. Then let's say you have the delay here, right? Delay, this is the subroutine. Then of course you have various lines, and then the subroutine ending with return. So when you're actually executing this particular line called delay, what happens is that the program counter will already point at the next instructions address, and it will keep this address into the return address stack. And then once it actually saves the next instructions address into the return address stack, what happens? The PC will now go from here, it will go to the subroutine. And then when subroutine, when it executes all the lines, and when he sees the keyword return, what happens is, remember the earlier address that was saved into the return address stack, that will be loaded back into the program counter, and therefore the program counter will know where to return, which is to the next line of instruction, and it will continue. So here in chapter 4, how do we call a subroutine? So this is a subroutine, right? This is a subroutine. So how do we call? We use rcall or we use call. But here in this chapter, topic 6, we will see it is also interrupt service subroutine. We also have the subroutine, but it is not called. You don't use called. We will actually configure it. Then once the interrupt happens, a trigger happens. So this trigger can either be from internal or can be external interrupt. Okay, so conceptually this is what we're going to see here in this chapter. We are going to have a subroutine, but the subroutine you don't call. We actually will configure the interrupt subroutine so that when the interrupt happens, then automatically it will go to the subroutine. So this is just the concept, opening concept. So how do we look at interrupt? Is that just like how when we are actually having a phone, just imagine that you are doing a particular kind of work. You are actually doing some work, then suddenly you receive a phone call. So what happens when you receive a phone call? You stop whatever work that you're doing, you attend to the phone call. So assuming here is where you receive the phone call, this is the task that you have been doing, then suddenly you receive a phone call, so you attend to the phone call, you answer. Then what you do after the phone call? You continue back your task, right? So the receiving the phone call is an interrupt. It actually interrupted your natural flow of work, right? So interrupt. But after what you did during the interrupt, when you receive the call, so maybe it's an urgent call or whatever that you need to have a conversation and things like that. So after you're done with the conversation, what do? Then you continue back your task, right? So that's the concept of interrupt. So we are actually going to see. So I'm not going to go through the flow chart now, but later when we actually explain the concept, it'll be easier. So when we look at interrupt maskability, so these are some of the terms, just bear with me. There are two types of interrupt maskability. One is maskable and non-maskable. Maskable interrupts are interrupts which you can enable or disable. So just say, for example, just to give an analogy, so you are studying, you're doing particular work, you're writing notes and things like that. Then you receive a phone call. That phone call, you have a choice whether you want to actually attend to the phone call or put it on silent, right? That is one sort of interrupt. But there is also another type of interrupt which is non-maskable, which means you cannot ignore. So let's say you are studying in a classroom, then suddenly you hear the fire alarm. So that is something that you shouldn't ignore and immediately must take action. So in a nutshell, that's what maskable and non-maskable means. Maskable allows you to enable, disable. Non-maskable, you cannot disable it. The moment you receive such interrupt, you cannot ignore and you have to take immediate action. So these are the some concept. So one example of non-maskable is reset. So when you reset a microcontroller, this is a non-maskable. So when you press the reset button, it will reset and establish back the initial values for the CPU register, flip-flops and all the registers. Okay, so these are the various types of resets which are non-maskable. So power on reset, microcontroller pin reset. So all these are various reset. For in this scenario, for you to just understand that this is actually a non-maskable. That means you cannot choose to ignore it. When you do power on reset, it has to reset back. Or when you click on the microcontroller pin reset, it has to reset back. So there's no way that you can disable it. So these are all non-maskable resets. So moving on, we are actually going to look at interrupt which are maskable. So we are going to look at interrupts which are maskable. Now prior to this chapter 6, I'm sure that you have seen this program start template, right? Where you write origin hex 00. So you usually write like this, right? Origin hex 00, you put go to start. Then you have origin hex 08. Then you have RETFIE. RETFIE stands for return from interrupt. Then you have origin hex 18, return from interrupt. So this is the program start template. So all this while you have only focused on this part. For this chapter 6, you will look into here. So what are things that you need to take into consideration is that what is this hex 00 called? This is also known as reset vector, right? We might have studied this earlier. Reset vector. So reset vector means whenever you reset the microcontroller, automatically the PC will point to this address 00, because this is the reset vector. The predefined address, whenever reset happens, the PC program counter will always go back to this address. So that is reset vector. Likewise, you have two more interrupt vector. So predefined address for interrupt vector. So you have to remember this, that hex 08, this hex 08 is actually the interrupt vector for high priority interrupt, and 18 is the interrupt vector for low priority interrupt. Okay, there are only two levels of priority interrupt in PIC 18, which is high and also low. And the interrupt vector, whenever a high priority happens, is 08, and for low priority is 18. So again, just bear with me. You will understand how does this all come into picture very, very soon. Okay, so let's move on. So for PIC 18 interrupts, there are two broad category of interrupt. The first one is known as core interrupt, and the second one is known as peripheral interrupt. So this is important because under these two categories of interrupt, there are what we call as interrupt sources. Interrupt sources means what are the source that can generate interrupt. So under the core group, these are all the interrupt sources: INT0, INT1, INT2, INT3. INT stands for interrupt 0. So these are all the various pins at port B. So INT0, INT1, INT2, INT3. These interrupt sources belongs to the core group interrupt. And then you have the port B pins change. This is also comes under the core group interrupt, and timer 0. So you just memorize this, that interrupt 0, 1, 2, 3, port B pins change, and timer 0 belongs to core group. Any other interrupt sources falls under peripheral group. Is that okay? So just now I mentioned about the interrupt source, right? For each interrupt source, we have what we call as control bits. There are total of 3 control bits that you need to configure to control its operation. So all these things are very important. For every interrupt source, there is a flag bit, there is an enable bit, and there is a priority bit. This flag bit, it will turn 1. It's just a bit only. It will turn 1 whenever there is an interrupt request. Whenever there's an interrupt request, the flag will become 1. Enable bit, of course, it is used to enable the interrupt. And priority bit is to select whether you want to select low or high priority. So take note, important that for each interrupt source, there are 3 configuration control bits that you need to do. So these are all the registers that are related to interrupts, which you need to know. So earlier I mentioned about core group, right? There are core group, there are peripheral group. For core group configuration, there is this RCON register, there is this INCON. INCON stands for interrupt condition register, INCON 2, interrupt condition register 2, INCON 3. And then for peripherals, you have peripheral IR, interrupt registers. So all these interrupt registers, there are 3, PIR1, PIR2, PIR3. So all these are all special function registers, PIE and IPR. So for peripheral, all these registers, PIR, PIR1, PIR2, PIR3, only contains the flag bit, whereas PIE, interrupt enable, it contains only enable bit. IPR only contains priority bit. So in peripheral, it is much more easier because it's all properly arranged. But for core, you have to search. Remember, for every interrupt source, you have 3 control bits, right? So the 3 control bits, you have to search. Where is it? Is it in INCON, or is it in INCON 2, or is it in INCON 3? And then this RCON register, you only will configure 1 bit. So this is compulsory. So first and foremost, you need to identify the interrupt source, whether which group it actually belongs to. So let's see if there's an example. Let me see if there's there's no example here. Let me just see if there's example. Okay, just hold on. Okay, let's see this example. Sorry, I think the example, the annotation forget to delete. So let's say write an instruction sequence to configure INT0 pin as no priority interrupt. So whenever you see a question, the first step that you need to do, okay, maybe let's see if I got a space here or somewhere here. Okay, I think here there's some space. So let me try to draw somewhere here. So let's say you write an instruction sequence to config INT0 as, so this Q, or maybe here, hold on, let me just check. So as no priority, right? So whenever you see such question, the first thing that you want to do is, the first step is you have to identify the interrupt source. So how do we know what is the interrupt source here? So look at this. This is INT0, right? So sometimes you see this kind of term, INT0, INT1, timer 0. So these are all the, if you see the previous, yeah, not this one, yeah, this one. So all these are interrupt sources. Port B change, timer 0 and timer 1, ADC, USART, etc. All these are interrupt sources. Okay, so the first thing that you want to do is you want to actually identify the interrupt source. So what is the interrupt source here? The interrupt source is INT0. The second question that you want to ask is, which group does this interrupt belong to? There's only two options, right? Either it belongs to the core group or the peripheral group. So which one? So if you remember correctly, under the core group, that is INT0, 1, 2, 3, port B pins change and whole timer 0. So this is under core group. Why we need to identify which group it belongs to? Because the next step is we want to configure the control bits. So based on the group, whether it's core or peripheral, then only we will know where the control bits are. Okay. So now let us try to do the configuration. So remember, whenever we want to do the configuration, the first thing that you want to configure is the RCON register. RCON register. This is a must. So, but this question says that without priority. So in RCON register, the only thing that you are interested is in pin number 7, which is known as IPEN. IPEN stands for interrupt priority enable bit. So if you make it 0, it will disable the priority levels on interrupt. If you make it 1, it will enable the priority levels. So in our case, what do we actually want to do? The question says no priority level, right? So that means the first thing always you want to configure, but this one, because no priority level, we're going to use bit clear F RCON and the bit name is IPEN. So this will make it no priority level. This is always the first step. The first step that whenever you want to do the interrupt configuration is you always configure the priority level. So this is always the first step, standard procedure. In most of the questions, it will always ask for priority level. So this part always it will be BSF, but in this case it says that no priority, right? So we'll do that. Next is what we want to do. Next step, so this one make it 4. The next step is we want to configure the 3 control bits. How many control bits there are there? There are flag, enable, and also priority. So take note that if you already disable the priority level, here even though if you set to high or low priority, it wouldn't have any effect. Okay. So now out of these 3 control bits, let's try to configure the first bit first, which is flag. So always remember that we always want to clear the flag bit. Why? Because remember earlier we mentioned that whenever the interrupt happens, the flag bit will become 1. So we always want to make sure that we want to clear the flag. Now for this interrupt source, which is in the core group, we need to find out where are the control bits. So the control bits will be in incon, incon 2 or incon 3. So let's see. Okay, so this is incon register. So can you search for INT0IF? Yes, you can see that is this INT0IF, right? So INT0 means interrupt 0, IF means interrupt flag. So it is there under incon. So what we want to do with this particular flag, a particular bit, sorry. So you can see that each bit in this register incon has a name. So we want to always, flag means always we want to clear. So bit clear F incon, this is interrupt 0 IF, that means you clear the flag. The next thing that you want to do is you want to enable the interrupt. So again you have to search where is the enable bit. So under incon, yes, we see that INT0 IE, this is actually the enable bit. So it's easy to identify the bits whether it's flag or enable just by seeing IE. So what we want to do, we always want to enable it. So enabling means bit set F incon INT0 IE. So flag done, disable done, priority. Now if you try to search under, let me see if you have incon 2 or incon 3. This is incon. So under incon 2 or incon 3, when you try to search, you will not find INT0 IP, which is interrupt priority. That is because for interrupt 0, by default it is high priority. So only for interrupt 0 there is no priority bit. So only for interrupt 0. Interrupt 0 has only 2 bits, flag and enable. There is no priority bit for interrupt 0 because interrupt 0 by default is high priority. Okay. So that means we have configured the 2 control bits, because for INT0 we don't have the third priority bit. All the other interrupts has priority bit, only for INT0 it doesn't have. So this is what we call as local enable. The interrupt still won't work because you also need to do another thing which is known as global enable. So there are 2 levels of enabling. So if you see here under incon, do you see this one, bit number 7? Bit number 7 is actually GIE or GIH, which stands for global interrupt enable bit. So in our condition is Currently, if we clear the IPEN and if you make it 0, it disables all interrupt. If you give it 1, it enables all interrupt. So in our case, we always want to enable the interrupt. So this is our current case where IPEN is 0. But in most of other cases, the real case or examples, always IPEN will be 1. But even though if IPEN is 1, you still have to write 1 to GIE or GIEH. You can write it as GIE or GIEH, both refers to bit number 7 of INCON. Then only the interrupt will work. So here you have to, so this one, step number 6, bit set F. This is also under INCON. This is GIE. You can write GIE or GIEH. This is global interrupt enable bit. So in terms of your understanding, you can either write GIE or GIEH. GIEH means global interrupt enable for high priority. So this one is global enable. So once you do this, then only the interrupt will actually work. So bear with me. As of now, we have only seen how to do the interrupt configuration. Okay, we will see one more example. Now what I want you all to understand is how do we do this configuration. Later you will have the bigger picture. Okay, the step is always identify the interrupt source, identify whether which group does it belong to, then you try to configure the control bits, flag, enable and priority. So when you write the code, the first thing is you always must configure the RCON, then you control the 3 control bits and global enable. This is always the step. So let's see one more example. I think there's one more example somewhere later in the slide. Sorry, I'm shifting the slide here and there. I'm recording on a tablet. Okay, so now here, another example. Write an instruction sequence to configure INT1 as high priority interrupt. So again, what's the first step? The first step is identify the interrupt source, which is INT1. Which group does it belong to? Core group. And the third step is now we need to configure the 3 configuration bits, right? So the first step, always you want to configure the RCON. So because here is high priority, you always want to set the RCON IPEN pin. So what this will do, this will enable the priority level. Okay, this is always must be there. Then let's try to configure. There are 3 control bits, right? The flag, enable and also flag, enable and also the priority bit. So we have to search INT0IF. So under INCON, if you search the top one is INCON. You find that if you notice under INCON 3, somehow or other INCON 2 is missed from this slide, but you can actually refer to your instruction set. You can notice that under INCON register is all mixed. You have GIEH, PIE, then you have timer 0 enable, interrupt 0 enable, then you have RB, this is port B, pin change enable, then you have flag. Likewise, if you see under the, what is this? Under INCON 3, there is priority, enable, flag. So it's mixed. But for peripheral, all the flags are in, the naming convention is easy. You know that all the flags are in PIR registers. All the enables are in PIE and all the priority bits are in IPR registers. So it's easy for the peripheral. So coming back here, the first thing you want to do is identify where's the flag. So INT1 flag is here, but it is under INCON 3, right? So what you want to do the flag, remember the flag always we must clear. So this is in INCON 3, and this is interrupt 1 interrupt flag. So you always must clear the flag. This is the standard. So flag done. Next is enable bit. Where is enable bit? So enable bit is here. Interrupt 1 enable bit is here. So it's also in incon. So what you want to do enable bit, you always want to set so that you enable. So if you clear, it is disabled. So this is interrupt 1 IE. So you enable. This is local enable. Local enable. Then you have the priority. So enable done. Now next is priority. So where is priority bit? So interrupt 1 priority bit also is here. So what do you want to do priority? So now this is high priority, right? So high priority means this 1. Low priority means it will be 0. So that means we need to set bit set incon 3 int interrupt 1 IP. So this is high priority. So are we done? No. We still need to enable the global enable bit. So which is GIH. So bit set F. This is incon. So we can write GIEH. Why? Global interrupt enable high. So even though if you don't write H is also correct, but this is just to make the in terms of context only lah. So this is global enable high. Okay. So you see that it is sequenced like this. Now in another case, what will happen if let me see if I can bring the eraser. Okay, I've erased it. Let's go back to ink. So let's say, sorry, what's not happening? Hold on. Okay, let's say now it is low. What changes in the code? So this one is the same, always archon. Flag, always you clear the flag. Enable, yes, you want to enable, but what happens to the high priority? So this one, instead of bit set F, it becomes bit clear F. So it will become low priority. Is that okay? Because we want to configure it as low priority. And then how about the global enable? Yes, this one is global enable is required, but maybe we don't write H, we just write GIE. Now one thing I want to bring your attention to this registers is that, just hold on. Yes. So this bit GIE, GIH, take note that we are looking at this one, this particular one. What it mentions here is it enables all high priority interrupts, right? What this means is that you always need to enable this GIE or GIH because it enables all interrupts and high interrupt. So regardless whether if it's not high also, it still enables all. So you always need to enable this. But here there is a catch. If you see at the 6th bit, there is also what we call as GIEL. So GIEL, when IPEN equals to 1, this one, it enables all low priority interrupts. So that means in this case, you also need to enable this. So in our case, this one, we also need to have an additional bit SF in con GIEL. So this is global enable all. This is global enable low priority. So what we have seen earlier is whenever you have high priority interrupt, you will have two levels of enabling. One is local enable and you have global enable. But whenever you have low priority interrupt, you'll have three levels. One is the local enable, global all GIE, and global enable all low priority. Three levels of enable. So high at 2 level enable, low has 3 level of enable. Okay, so we will stop here for this first session. Any questions you can actually post in the Telegram group so that we can try to understand together.